All right, guys, sorry about that. My computer doesn't seem to want to cooperate and unfreeze. So rebooted it and let's see if we can do this. So here we go. We are going to go from grams of what we know to moles of what we know. We're going to use our mole ratio to get into moles of what we want to know. And then we're going to go to grams of what we want to know. And this is stoichiometry. So example 4, what mass of oxygen is required to react with 100 grams of iron to produce iron 3 oxide? The very first thing we've got to do is create an equation. So here we go. We're reacting oxygen with iron. So remember, oxygen is diatomic. So it's O2, and we're reacting with iron. So then we need to figure out iron 3 oxide. That 3 tells me I've got iron plus 3, and oxygen is a -2. Okay, so what ratio do I need to put these in? The least common multiple between 3 and 2 is 6. So that means I'm going to need 2 irons and I'm going to need 3 oxygens to get to charges of +6 and -6 respectively. So 2 irons and 3 oxygens. Now, notice there's our skeleton equation. Now we need to go back through and we need to balance this equation. We have ratio of 2 oxygens to 3 oxygens over here. So once again, our least common multiple is 6. So 2 times 3 will give me 6 oxygens, and 3 times 2 gives me 6 oxygens. So I have the same amount of oxygens on both sides. Now I need to look at my iron. So 2 times 2 is 4, so I need to put a 4 in there. Okay, so notice that this is the same equation that we dealt with at the very beginning of our stoichiometry lecture on our first video. So now the next step is to take what we know in grams and convert it into moles. So I've got 100 grams of iron. 100 grams of iron. I need to look on my periodic table to figure out how many grams of iron are in 1 mole of iron. Does anybody remember? It is 55.85. 55.85 grams of iron are in 1 mole of iron. Okay? So there's my first step. I want to convert my grams to moles. And it's the moles of what I want to know. So I'm going to take 100 and I am going to divide it by 55.85. So grab your calculator, 100 divided by 55.85. And we are going to get 1.79. Let's see, I've got 4 sig figs, 7905. So 791 moles of iron with our 4 sig figs. The next step then, I've got one step done. I now need to take that moles and I need to convert the moles of the iron into the moles of oxygen, which is what I want to know about. Okay, so I have 1.791 moles of iron, and I need to go from moles of iron to moles of oxygen. So I'm going to grab my ratio. I have 4 moles of iron reacting with 3 moles of oxygen. So I'm going to put 4, that didn't convert very quickly. 4 moles of iron react with 3 moles of oxygen. Okay, so my moles of iron cancel and I now have moles of oxygen. So if I multiply my 1.791 by 3 and then divide it by 4, I get 4 sig figs, 1.3428, so 3 moles of oxygen. Okay, so I'm not done. Now I need to take the moles of my unknown substance into grams. Okay, so I'm going to take my 1.343 moles of oxygen, and in 1 mole of oxygen, and remember oxygen's diatomic, I have 32 grams of oxygen. Okay, so I'm going to take that and I am going to take 1.343 and I'm going to multiply it by 32. And with sig figs, I get 42.98 grams of oxygen. Okay, now we are going to do this all in one big step. Notice we had to round here, we had to round here, and we had to have round here. So if we do this in all one step, we only have to round once. So it's actually going to reduce our rounding errors as well as making it easier. So here we go. We're going to do the same thing. 100 grams of iron. Okay. And in 1 mole of iron, I have 55.85 grams of iron. Okay. Next is to grab this mole ratio. I have 4 moles of iron reacting with 3 moles of oxygen. Okay, so grams of iron are gone, moles of iron are gone. I now have moles of oxygen. And then the last step is to go from moles of oxygen to grams. So 1 mole of oxygen, and now my computer's glitching again. So 1 mole of oxygen, 2 grams of oxygen. Now remember, oxygen is diatomic, so 32 grams of oxygen. So my moles of oxygen cancel. I have grams of oxygen, which is exactly what I wanted to know. I wanted to know how many grams of oxygen. Now, remember, everything on the top is a multiplier. Everything on the bottom is a divider. So let's do this step by step. I'm going to take 100 divided by 55.85, multiplied by 3, divide by 4, and then multiply by 32. That will give me, I've got 4 sig figs here. I've got 4 sig figs here. This is a definition, so it's unlimited, and I've got 4 sig figs right here. So I can do 4 sig figs. So 42.97 grams of oxygen. Notice our answers are a little bit different. This answer up here had a whole lot more rounding. So this answer that we just produced is actually more accurate. Okay, so let's do this one. Number 5, how many grams of oxygen would be needed to burn 30.5 grams of propane? The products, of course, because we are burning things, right? This is combustion, is going to be carbon dioxide and water. So the first thing we've got to do is create an equation. So I'm going to take propane, C3H8. I'm going to burn it in the presence of oxygen. I'm going to create carbon dioxide and water. Okay, remember when we balance these equations, we do carbon first, we do hydrogen second, and we do oxygen last. Okay, so I got 3 carbons. So let's do 3 here. I've got 8 hydrogens. So 8 divided by 2 is 4. Now let's look at my oxygens. 3 times 2 is 6, plus 4 times 1 is 4 is 10. 10 divided by 2 gives me 5. Okay, so there's my balanced equation. Now we want to compare oxygen to propane. So we're going to do our mole ratio. 1 mole of propane to 5 moles of oxygen. Okay, so we're going to start with 30.5 grams of propane, which is what we know we have, right? We got 30.5. right here, 30.5. Okay, so I have 30.5 grams of propane. Let's do our molar mass. So C, I've got 3 of them, and carbon is 12.01. And hydrogen, I've got 8 of them, and hydrogens are 1.01. So we need to come up with this molar mass. So 3 times 12, 36.03, and 8.08. So let's see, 0.11, and then 44.11. Okay, so we've got 44.11 grams of propane in 1 mole of propane. Okay, so I've done the first step. I've done grams to moles. Now my second step is to go from moles of what I know into moles of what I want to know. So I'm going to grab this ratio right here. I have 1 mole of propane reacting with 5 moles, right? That 1 is implied, 5 moles of oxygen. Okay, so my moles of propane cancel, and now I have moles of oxygen. My last step is to go from moles of oxygen to grams of oxygen. So in 1 mole of oxygen, I have 32 grams of oxygen. Okay, so my grams of propane cancel, my moles of propane cancel, my moles of oxygen cancel, and I now have grams. So let's do the math. So 30.5 divided by 44.11 times 5 times 32. We've got 3 sig figs here. So my calculator gives me 110.6. That 6 tells me to raise it up. So 111 grams of oxygen is what I would need to combust that propane. Okay? Last example here. How many grams of air would be needed to burn the same amount of propane? Okay? So air is 20.7% by mass oxygen. Do you think we can figure this out using our unit analysis? We sure can. So we're going to start out with my 30.5 grams of propane, and we're going to use that same balanced equation. Okay? Or we could just start off with our 111 grams of oxygen. Either way. Let's actually do the simple way. So if I have 111 grams of oxygen, now, can we use this to create a ratio? That means I have 20.7 grams of oxygen for every 100 grams of air. Okay, I want to cancel out my grams of oxygen, right? So I'm going to put this 20.7 on the bottom. 20.7 grams of oxygen gives me 100 grams of air, right? Okay, now, if I use the 111 divided by 20.7 multiplied by 100, I will get 536.23. So the 3 sig figs, I will get 536 grams of air that I need. If I end up using what my calculator left in here, which is 110.6325098 grams of oxygen, and I don't round, and I do this same thing, 100 grams of air divided by 20.7 grams of oxygen, that same thing, I will end up, let's see, I end up with 534 grams of air needed. So notice how much rounding changes what's going on, okay? So when you are calculating something, don't round until the very, very end, okay? So that is stoichiometry. Stoichiometry in a nutshell, we go from grams of the known to the moles of the known to the moles of the unknown to the grams of the unknown. And we do that all by using our mole ratio from the balanced equation. Okay? So stoichiometry, if you balance your equations and you pay attention to your unit analysis, stoichiometry is basically just using balanced equations and unit analysis. All right, have a great day. If you have any questions, please email me or please talk to me during Flex. Thanks, bye.